Hey guys, welcome back to the channel. So today I'm going to explore interesting data set. So where every day we are gonna look at the data in TV, news, somewhere else. We might find all these details. So the data set today we are gonna explore is crop production in India. So I have a data set with um, state-wise data and also crop-wise details. So let us start the session. And so first I have imported all the required libraries, pandas, numpy, and also I want visualization tools, a matplotlib and seaborn. And also I don't want to see any warnings in my Jupyter notebook. So that is the reason why I imported warnings. So let me run this. So I'm able to import all the required libraries. So this is my data set, crop production. So I have taken this data set from Kaggle. So Kaggle is like a data sets repository where you wanted n number of data sets, and you can take a data set and you can do your EDA, or you can do some predictive analysis. You can do some, you can prepare a machine learning algorithm as well. So if you wanted to explore different kinds of data sets, go to Kaggle and search whatever your requirements are. Just search with the keywords and you'll be able to get a lot of data sets. Then download one data set and start doing EDA on different types of data sets. So this one is also taken from Kaggle. So this is personally my favorite data set, because crop production in India, every day we are gonna uh, listen about all these things in news channels, or in day-to-day life also we might talk about these things. So it is a very interesting data set to look at the data, how it is there state to state, year on year, something like that. So I'm assigning my data frame to a variable called df. So let me run this. And also first let me look at my data set. So here I have around 2,46,091 entries. So 2,46,000 entries, and I can see some null values in production. So apart from production, I did not see any null values. State, district name, crop year, season, crop area, production. So these are the my column details. So this is like entire all the state details, entire 28 states, and I think it included some other like union territories also. I'm not sure. Let me explore the data, then we'll be able to get that details as well. And also we have a column for district names. So district wise also data, we have crop year, year on year data, season wise data, and the crop type. It could be like wheat or rice or different type of crops, and the area, total area, and also the production. The final is like production. So we are gonna, so this is like a normal exploratory data analysis. In coming videos, I'm gonna do some predictive analysis by using the similar data sets. Like we are going to predict the production in upcoming years based on the history. So we will apply some machine learning or we will prepare a machine learning model, then we will try to apply it. So in our future videos, I'm gonna explore the same data set for predictive analysis, but this time I'm just wanted to explore the data only. It is normal exploratory data analysis. So these are my columns in my data set. So first I just wanted to set the styles, because whenever I wanted to visualize any data, I wanted the background is like white grid, and also the peak size I wanted is 12 by 8, x-axis length is 12 centimeters, and y-axis length I want 8 centimeters. So that is the reason why uh, I I set these values. So SNS dot set style, if I give white grid, then I'll be able to see the background grid is white color. Then PLT dot figure. fig size, I wanted 12 centimeters x-axis and 8 centimeter y-axis. So let me run this so that I can use it in further. So if I wanted to look at the statistics of my data set, so let me run df.describe. It will give me, so since you can see all the other columns are in object data types, but only crop year. So since it is an integer, years are represented in numbers, right? So that is the reason why it is in int 64. And also area is obviously represented in numbers, so that is why it is in float. And production is also in numbers, so that is why it is in float 64 data type. So apart from these three columns, I can see state name. Obviously it is a categorical column, and also district name. So these are also, we do have some categories of names. So categorical column, that is why it is updated as object. And seasons also, we do have multiple seasons, summer, winter, rabi, kharif, something like that. So that is the reason why it is updated as object categorical data type. And also crop, so the different types of crops, so obviously it is a categorical data, so that is the reason why it is updated as object. So if I wanted to look at the statistics of my data set, so here you can see, let me transpose it so that I'll be able to see the data in a simple or easy way. So here I have a crop year. So I do not have any null values. Total count of the entries are 2,46,000. Then the mean year is 2005 and the standard deviation is 4.9. Then the minimum means the starting year. In the data set, I have the starting year is 1997 and I do have the data from 2015. So this is for year. And if I look at the area wise, I have do not have any null values, and these are the total entries. And the mean area is 12,000, and the standard deviation is 5.05, and this is the minimum value. This is 25th quantile, 50th quantile, 75th quantile, and this is the maximum value. And whereas this is for the production details, number of entries, the mean production from 2005 to 2015, mean value, standard deviation, minimum, 25th, 50th, 75th, and the maximum production. This is the maximum production. So this is how, if you wanted to look at the data and if you wanted to look at the statistics of the given data set, you can apply just data frame.describe, then it will give us nice details about all the statistics. Then if I wanted to see if I wanted to see is there any null values present in the data set or not, I can see by using this df.info. Here I'll be able to see there are few null values of 4,000, around 4,000 or 3,700 null values are present. But I just wanted to see the null values in a visual. I just wanted to visualize the null values, not only by looking at the info, but I wanted to visualize the null values. So there is a syntax for that. So I wanted to visualize the missing values with Cbon. So heat map, with the use of heat map, we'll be able to see some null values. So I'm passing this df.null, and the color bar is false, and I'm giving color map is word is, then the title I'm giving is missing values. So let me run this, then I'll be able to see the missing values. So only production we have, apart from production state name we do not have. So always if you run this above code, so you'll be able to see null values in yellow color. So here you can see there are some null values in production. So that is what we have. I mean, we got the information above also, but here it is a visualized representation of above details. So as we do not have any null values in any of the column apart from production, so that is the reason why we do not see any yellow lines. So here we do have some null values in production. So like in production, we have some null values. So that is the reason why we can able to see with the help of heat map. So this is how we can look at the data with a heat map. And also, so if I wanted to look at the data once, so let me see the head of the data, what are all, how the data look like. Yeah, even the union territory is also included. So the first Andaman and Nicobar Islands, and the district name is their crop year, and this is season like Kharif, Rabi. So we do have some season, right? Which is the suitable season for different types of crops. Summer, rainy season, winter season, Kharif, Rabi. So in India, so we do name seasons with a name like Kharif and Rabi. And the whole year means nothing but that crop can be uh, produced in any time of the year. So there is no specific season for that particular. mm, like this crop banana, it can be harvested entire year, and also cashew nut also there is no particular season. And this is my head of the day. If I wanted to look at the data for first 25 entries, let me look at it. So all the 25 entries are for this Andaman and Nicobar only, but you can see this data 2000, from 2000 we have, and you can see crop details with the area and the production from. So if I talk about this, the first row, this is for district name Nicobars, and the crop year is 2000, and this is for Kharif, and the crop name is uh, Acrinot, and the area, how much it was harvested is 12,054 something, it could be hectares, and the production is 2000. Maybe it could be in metric tons or something like that. Even I am not aware of these terminologies, but this is how you can see. So the state name and district name, crop year, season, and the crop name, area, and the production. So this is how you can, this is my top 10 or top 25 entries of the data set. So that is, and if I wanted to look at the state name distribution, because so if I wanted to look at the uh, number of states and with the entries, unique values. So these many states I have 33,000 entries from Uttar Pradesh, obviously, which is the largest state in India, like population wise, and then MP, Madhya Pradesh, then Karnataka, Bihar, Assam, Odisha. So as per the data set, these are the entries. So as per my data set, I have 22,000 entries from Madhya Pradesh and Karnataka, followed by Bihar, Assam, Odisha, Tamil Nadu, Maharashtra, Rajasthan, then Chhattisgarh, Andhra Pradesh, West Bengal, Gujarat, Haryana, Telangana. So we do have this number of entries from each state. And so I just wanted to plot the above details with the Seaborn. So now I'm using, I wanted the size of the bigger is like x-axis 14, then y-axis I wanted 10 centimeters. Then I gave, uh, now I wanted to represent a horizontal bar chart now, because a lot of states are there even. So that is why I wanted to represent in y column. So y is equal to, I'm giving the state name, and my data is df, and I'm giving the color. This is so in order to get the styles for the bars. So, and I wanted value counts, so same above. So order I wanted in the counts, number of counts. So I'm giving the title size and the X label, Y label, and if I run this, I'll be able to see. So as we see, as per the above number, Uttar Pradesh is largest production of all the crops combined data. This is not only for a single crop, so it is combination of all rice, wheat. We are gonna look at the type of crops in next code, but this is for entire entries, combination of all the crops. So we do have more data from UP, then followed by Madhya Pradesh, Karnataka. So this is how, if I wanted to look at the data in a visualized manner. So above data, it can give me the numbers. And if I apply the same thing by using Seaborn, I'll be able to see the state-wise distribution of the data, state name distribution. So UP, we have 33,306 entries from Uttar Pradesh. So this is how you can look at the data state wise. And if I wanted to look at a crop year distribution, so as we see, and also first I wanted to look at the year value counts. Mhm. Crop year. I mentioned year. It should be crop year. Okay, so we have data from 1997. So it got sorted from highest to lowest. So that is the reason why we have year order in jumbling order. So you can see data for 1997, and the latest year is 2015 we have. So we have 562 entries. So this is how the almost 1997 to 2007, 18 years data we have for the crop details in India. So I wanted to look at the same thing in by using Seaborn. So same thing, I am giving the crop year, and this time I wanted to look at the distribution, not only the numbers, how the data distributed on year. So that is why I'm using histogram. Histogram will give me a nice detailed distribution about the data. So my data is DF of crop year. Then I wanted 30 bins, and I'm setting the KD is equal to, and color is, I'm giving the some styles. So this is the title and X label, Y label. So if I run this, then you can see the data, how the data is distributed. So you can see as it is started, as we have the data from 1997. So it could be around I can say 8,500, something like that. The frequency is in 1997 it started at 8,500, then it got increased. The crop production is very high in 2002. Then it was almost similar from 2000 to 3, I guess 3 or 4, 2000, 2004 to 2012. The production of the crop is almost similar. The distribution is very similar, identical. But whereas 1997 to the 2002, it is exponential manner increased. Then we have the data. We do not have complete data for 2015 years. So that is the reason why, as per the data, it is something like this. So this is how you can look at the crop production year on year. So for 1997, this is then the 2000, 2002, 2005, 2007, 2010. So the frequency, you can see the frequency and also the distribution. So year on year crop production is like this. And also if I wanted to look at area wise data. So here we have a column for area also. Okay, so this one, so I just wanted to see the area wise details. Then my data is area, then number of bins, the same thing, but I wanted to look at the distribution of the data area wise. So area wise data is similar for all the years. So see, this is how the frequency is more at 0.1, something like that. Then it is 0.2, 0.3, 0.4. So the distribution of the data is at 0.1 to 0.5 only. So the area wise production. And similarly, if I wanted to look at the production distribution, so production distribution by using same histogram, if I wanted to see the distribution of the data, it could be same 0.01 or 0.02, the production and the frequency. Frequency of 2.5 is at 0.01, 0.002, something like that. So this is how you can see the production distribution as well as the area distribution. And if I wanted to see area versus production, how much area is, I mean, how much production we are getting from area. So this is my area and this is my production. So at 0.1 or 0.2, there will be a production more 1.2, and you can see I gave this HUE is equal to season. I'm giving it for season, so that is the reason why all the seasons are represented in colors. So my Kharif season is in blue color. So wherever the blue color is there, so that is where my Kharif season crop production will start. Then the whole year, autumn, then Rabi, summer, winter. So we do have 6 seasons. So this is what the production versus area-wise distribution, the data distribution. And also, if I wanted to look at the correlation, how the each columns are correlated. Like, see here, one means my crop year versus crop year. So they obviously the perfectly correlated because both are the same similar columns. So that is the reason why these both columns are perfectly correlated. But whereas crop year versus area, there is nothing negative correlation. The something one is increasing, then other will be decreasing. So that is the reason why the correlation between crop year is and area wise, those are not perfectly correlated. There is a negative correlation. But if I look at the crop year versus the production, there is a correlation, very slightly positively correlated. But if I look at the entire correlation matrix heat map, so the area and production is like perfectly like the positive correlation is there. Obviously, if there is a area, bigger area, then we can expect production. There is an increase in the production. So lesser area, less production. So that is how you can see. So there is a correlation between production and area. So area and production. So by using the correlation matrix, we will be able to see how the columns, each columns are correlated together. So that is how we can see. And also, if I wanted to look at pair plots also, now I'm just using this pair plot, and I'm just again I'm giving HUE is equal to season, and this time I wanted to set to. Then these are like styles, that is you can give as per your requirement, and this will give me like crop year, and this is the year on year like 2020, 2000, 2005, 2010, 2015, and this is for Kharif. This green line is like, so from 2000, the crop year. So this is how see the like the production is the crop production and season on season. So you can see this nice pair plot. So and this orange is for a whole year, and this is for autumn, and this is for pink is for Rabi, and this is for summer, and this is for winter. So this is how you can see by using pair plots. So area wise and production wise crop. See production and area wise we have this matrix. So this is how you can see the correlation between columns by using pair plots. So and the production by season and crop. So if I wanted to look at the crop production season on season, obviously I have 6 seasons listed in my data set, and I wanted to see where in which season I'm getting more crop production. So I'm giving my x-axis is season and y-axis is production. I wanted to get the data for season versus production. So my data is DF, and this is my styles I'm giving, and production by season. So this is how you can see I'm using a box plot. I wanted to see see here it could be production in hectares or metric tons, I guess. So Kharif season we have very less. So this is at 25,000. So I can say that it could be at 5,000 or 10,000. So 10,000 metric tons from Kharif season, and this is for a whole year. This is for autumn season, and this is for Rabi, and this is for summer, and this is for winter. So if I look at the production season on season, for winter season, we do have more production as per the given data set. So this is how you can see uh, or we can able to understand that if I look at the season wise, so winter season we are getting more crop production in India from the given data set. And also if I wanted to look at crop wise, this is season wise, and also if I wanted to look at crop wise, so we do have a number of crops are listed, so that is the reason why it is very clumsy, we are not able to understand what is what. But here you can see it is cashew nut, banana, rice. So the rice, obviously the rice production is very high in India, especially in West Bengal, Andhra Pradesh, Telangana, and also there are in south states also the rice production is very high. Whereas when it comes to some north states, so you can see a very high production for wheat. Where is wheat? So this is how you can look at the data by crop wise. And if I wanted to see area and production over years, so on given year, how much is the production and how much is the area utilized. So this is where you can get, so this is area over years by season. So in 1997, so which is at 4,000, 40,000, sorry, 42,000 hectares. And the so season on season, so this is for Kharif season and this is for winter. So this is for winter. Obviously, the winter more area utilized because we are getting more production, crop production in winter. And this is for autumn and this is for whole year. So this is how you can see the crop year, and this is for production over years by season. This is area and this is for production. Production is more in obviously whole year, and this is for Kharif and Rabi, summer, winter. So this is how you can explore the data. So on my given data set, I have some columns. Then we looked at the data as per the season wise, on which season we are producing more crop, and also area wise and also state wise. If I look at the state wise, there is a lot of entries are from Uttar Pradesh, then followed by Madhya Pradesh. And if I look at the districts also, there are a number of districts are listed. So I cannot look at a single district because states only we have around close, including states and union territories, we have 30 plus entries. But if I look at the district wise also, then that will be like we will get more than 1,000 to 2,000 entries. And we looked at the data year wise, on which year the more crop is produced, and also season wise, kharif, rabi, whole year, and also winter. So there are few crops like the season, they are not dependent on seasons, they can be produced at any point of time in the entire year. And so we will be having, and also we looked at the production area wise production, and also crop wise production, season wise production, district state wise production. So that is how we explore this data set. So in coming days I wanted to build a machine learning model to predict the future production by, and I wanted to create a machine learning model with the historic data. It I will use some machine learning. So we are gonna uh, talk about all these things in coming videos. So I hope I have covered everything in this video. And if you have any questions or doubts, please feel free to comment on the video. And don't forget to subscribe the channel. So thanks everyone. Bye.